In this media, we'll discuss about boiler and feed water treatment. As you all know that in our series of videos, we are trying to cover all the surveyor expected questions and its answers. The topic we chose is boiler because I was receiving several requests from people regarding boiler, and we'll try to cover all the aspects of boiler. Previously, we have covered many such topics on boiler, and including even what we are doing is a hydraulic test of the boiler when we are laying up of the boiler, general maintenance of the boiler, alarm, trips, all these things. So I have made these notes taking from different sources, so that is why, and try to meet in a simple words. So wherever required, I will take a pause and then we'll just elaborate. Otherwise we'll just read it because it is self-explanatory. Okay, so following are some problems which can arise in boiler and in feed water system if boiler water and feed water condition is not maintained or neglected. Now the first problem that will occur is the formation of scale. So this scale, when we speak about, that comes only in, it should come only to our mind, is that chlorine. Now chlorine, it is when coming, because see, when we are adding this chemicals in the boiler regularly, we are doing boiler water test and then we are adding chemicals in the boiler, that we'll see on the further. Now this scale is because of the salt formation or the carbonate compounds. Okay, calcium carbonate. Okay, now to that sticks to your boiler tubes. When it sticks to your boiler tube, the efficiency of your boiler will reduce because the heat transfer ultimately will reduce, because boiler is all about your heat transfer. If you will not have better heat transfer, you will not have better steam formation. Okay, scale information in boiler leads to lower efficiency because of reduced heat transfer rate, as we discussed. Overheating 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 and tube failures may result in often high cost of chemical cleaning. To remove scale formed may be incurred. Typical constituents of scales and deposits in boiler are calcium carbonate, calcium sulphate, complex silicates of magnesium, iron, sodium, calcium, aluminium, calcium phosphate, magnesium hydroxide, magnesium phosphate, iron and copper oxides. The salts of calcium and magnesium are the major source of scale problems. All efforts should be taken to prevent presence of these salts in feed water by using good quality distilled water with low ppm of salts as makeup feed. If raw shore water has to be used, then chemicals are used to modify the scale former so that they are precipitated as relatively non-adherent sludge which can be blown out of the boiler before any scale forms. The use of treatment chemicals in boiler must be kept minimal to prevent problems, as excess use chemicals will lead to more harm. The common chemicals used to prevent scale formations are, now you'll see the chemical. Now you see because of what things that will occur condition. First one is sodium phosphate, used for precipitating the calcium salt from solution as calcium phosphate sludge. The important types are disodium phosphate, Na2HPO4, trisodium phosphate, Na3PO4. Okay, now sodium hydroxide, that is NaOH, also known as caustic soda. This even we are using at our daily use in our home. It is used to precipitate magnesium salts to as magnesium hydroxide sludge. Excess of alkaline salts in a boiler together with effects of operating stresses will produce conditions known as caustic cracking, which reduces metal thickness and causes weakening of boiler plates. This is very deadly situation. Coagulants like sodium aluminate, starch and tannin are also used, which combine with the scale forming salts into a sludge and stop it from sticking to the boiler surface. Blowing down the boiler later will help to get rid of the unwanted sludge. So when we are blowing down, we know that we are doing two types of blow down, that is bottom blow down and scum blow down. For salts and deposits, heavier deposits, we are doing this boiler bottom blow down. Okay, and scum blow down for lighter particles which are floating on the boiler, which are foreign particles. Okay, we'll not go in detail, you can watch the videos on blow downs and all. These chemicals are normally added as dilute solutions and fed directly to the boiler by high pressure dosing pump in small and metered amount. Now, small amounts of chemicals added regularly are much preferred to large infrequent doses. Subsequent testing of boiler water is essential to monitor the effects of the chemicals, and further actions is taken based on the test results. So further action we are taking based on that. Now, other problem of apart from this salt formation, scale formation, sorry, we have is corrosion. When we speak about corrosion, the presence of oxygen in the feed water can cause serious effects on the metals of the system. It can give rise to feed line corrosion, with the formation of corrosion products of iron and copper also causes reduction in the effective thickness of the metal used to construct the feed system. These iron and copper oxide are carried further through and will tend to accumulate in the boiler. Even if adequate blowdown has been regularly carried out, such oxides, particularly when deposited on generating tube surface, restrict heat transfer and thus lead to creation of dangerously high metal temperature. Any oxygen not used up in the feed water and which reaches the boiler through the feed water will not give rise to serious problems, as the bulk of it will be expelled and gets carried over with steam. However, when oxygen attack takes place in the boiler, it causes localized deep pitting which can lead to tube failure. Now this condition will lead to tube failure because there will be ultimately pitting. Here also thinning was happening, okay, weakening of the boiler plates because of the caustic cracking, because of the scale formation. In corrosion also same problem is carrying. Carryover and priming. Carryover is the phenomena of water droplets being carried over with the steam into the steam system. So this carryover phenomena, phenomena of water droplets into carryover into the steam system. You see, we have now superheaters, okay, superheated steam, saturated steam. Okay, the reason being of is this only because we want to avoid the carryover. If the impurities like suspended solid, excess of salts or oil in the boiler water increases, then foaming may occur. So now this causes your foaming condition. Now this foam or froth collects on the water surfaces in the boiler drum. Foaming leads priming, which is carryover. Now foaming leads to priming and this leads to carryover. So now any foreign particles like suspended solid or the salt in, now when they enter, they may cause foaming. Now this foaming leads to your priming, which is carryover of water droplets along the steam system. The dissolved and suspended solids which are carried over through the water droplets will later evaporate and leave behind deposits in superheater section or perhaps or turbine blades. Now if your ship, that is VLCC or Suezmax, that is running through your the COPT's cargo oil pump turbine, we have covered differences between cargo oil pump turbine, alarms and all these things in a separate video. Please do watch on cargo oil pump turbine video. Perhaps the turbine blades, so that will erode, that if that hits the blade of the turbine, then their erosion problem will occur. So see, one problem is leading to other consequences and other problem, failure of machineries and all these things. So the total feed flow to any boiler normally comprises a small quantity of makeup water to replace water lost from system by way of leakages or as steam or blowdown, together with the condensate recovered from the steam. So through the condensate there is a makeup line. Through this we are replacing this water which are lost in different situation. Makeup feed. The quality of makeup feed is very important in maintaining boiler water condition. On ships which do short coastal voyages and operate close to shore may run short of fresh water and depend on shore water. This raw shore water contains many impurities and dissolved salts like calcium bicarbonate, CaHCO3, calcium carbonate, that is CaCO3, calcium sulphate, CaSO4, magnesium sulphate, MgSO4, sodium chloride, NaCl, sodium sulphate, Na2SO4. It is a calcium and magnesium compound which can cause the most trouble, okay, since they lead to scale formation. So remember always that this when we speak about the scale formation, calcium and magnesium should come to our mind. The water soluble salts do not form scale but increases the TDS in the boiler water, thus increasing the necessity to blow down more frequently. Hence, evaporated seawater made in the freshwater generator with low ppm of soluble salts is the most preferable source of makeup feed for boiler. So evaporated water that we are using for makeup, that is the that we are generating it from the freshwater generator, that is the most preferred way for what type of ship? For ship which are doing coastal voyages, which depend on the shore side for their water. For water tube boilers and boiler with high evaporation rate, only distilled water should be used as makeup feed, as they are very sensitive to scale formation. Now condensates, when we speak about the condensates may pick up copper from copper alloys used in condenser tube material. Ingress of seawater through leaking condensers tube aggravates the problem further. So now this will ingress of seawater, if there is a condenser and if there is an ingress of seawater, this will further aggravate the situation. Total feed water. The treatment of total feed water will vary according to the type and steaming condition of the boiler concerned. Oxygen and CO2 dissolved in the feed water causes serious corrosion in the feed system, and hence feed water has to be deaerated and the dissolved oxygen removed either mechanically or chemically. Mechanical deaeration is achieved by use of feed water heaters and passing feed through deaerators. So we are passing it through feed water heaters and deaerator. Now for chemical treatment, what we are doing, we are using is what is known as oxygen scavenging, like hydrazine, okay, and 2H4, or catalyzed sodium sulphite. Sodium sulphite will combine with oxygen to form sodium sulphate, which results in formation of additional dissolved salts in boiler, hence not preferred. So this is the equation. Hydrazine will react chemically with oxygen to form nitrogen and water and will not increase dissolved solids, hence it is preferred oxygen removing treatment chemical. So that's where if oxygen is there, we are using hydrazine. Carbon dioxide in the feed water system also combine with water to form carbonic acid. Now carbon dioxide leads to the problem of formation of carbonic acid. Now what will happen? This acid will dissolve ferrous metal both in the boiler and condensate system. The alkaline boiler water will counter the acidity, but the carbonate formed will decompose to form CO2, which will pass over with the steam and dissolve in the condensate, thus causing corrosion in the feed system. Hence, some method to eliminate the CO2 is essential. The most common method is to use the ammonia formed by the decomposition of excess hydrogen alone or in conjunction with volatile amine, as both chemicals being alkaline in nature and volatile in the steam are capable of neutralizing the acidic gases such as CO2. Hence the amines and hydrogen treatment is done by injecting it in the feed line by a high pressure dosing pump, so it will enter the boiler directly and not evaporate as it would have it added direct in the hot well. Okay, so we are doing it direct injection. So whatever we discussed, I have just summarized, summed it up. I know you must be wondering why I am reading all these things, because I have taken the content from different sources and I have tried to make it here in simple terms. These are self-explanatory and my idea is not to teach you at all. So when we speak about in boiler water treatment is required for the following: to keep the hardness salt in suspension in the boiler water to prevent scale formation. So we want to prevent the scale formation. To stop any suspended salts and impurities from sticking to the heat transfer surfaces. To provide anti-foam properties and stop water carryover. To eliminate dissolved gases and providing some degree of alkalinity which will prevent corrosion. So these were the things and these were the problem of scale, corrosion, all these things what we discussed today. It is very important. This was a direct question that was being asked by the surveyor. Thank you so much. Thank you for your valuable time. All the very best for your future endeavors.